these modules haven't been charged or discharged for about 5 months. When no load applied to the battery poles, what you're measuring with your digital voltage meter is so-called open circuit voltage. That gives you no indication of the battery state of health at all. But if you apply load and current start to flow from the battery to the load, that's how you measure the closed circuit voltage. Let's apply the load to this battery, and the load in this case is this 12 volt bulb. You see how the voltage immediately dropped to 6 volt. And you'll see how the voltage goes up again when you remove the load from the module. It may well go up again to 7.2 or above volts, which I'll show you in another test. You can see that the voltage measured on the battery poles, or so-called open circuit voltage, is above 7.2 volts. It's now 7.62 volts DC. Although it shows 7.47 volts, it may look like a good battery. You can't tell with measuring closed circuit voltage whether this module is a workable module or not, and how well that module will perform in a Prius. Knowing the closed circuit voltage is not good enough. Knowing the remaining capacity of this module is also not good enough. What you need is to conduct the comparative test on all the modules connected in series and load it with the same load, and the measurements been taken simultaneously on the individual module level. If you remove the load, the voltage will go up quickly. You can see the voltage goes up again quickly. And if you source a module like that and put into your battery, most likely the battery pack would not perform. It will fail. Measuring so-called open circuit voltage when no load has been attached to the battery poles doesn't give you indication of the state of health of that module. It's currently 7.49 volts, which one may think is pretty good. I'm telling you that it's pretty bad, because I know the capacity, remaining capacity of this module under the load. It's very low, and the module will not perform in the battery pack. But knowing the remaining capacity of the module is not good enough. What you need to do to rebuild the pack is to compile it from the donor modules with the known remaining capacity, but the test has to be conducted on all modules connected in series under the load and modules have to perform in conformance with each other. Now we are measuring the closed circuit voltage. Load has been applied to the module. Current flows through the load, and you see that the closed circuit voltage drops quickly. When we remove the load, the voltage measurement will be open circuit voltage measurement, and that will go up again quickly. The closed circuit voltage dropped quickly to 7.2 volt. Now it goes below. This module is pretty bad. You can tell by conducting this quick closed circuit voltage test. When we remove load, the open circuit voltage will go up quickly again. So you can't really tell by testing modules with the digital voltmeter and measuring the open circuit voltage how good or bad the module is. You can roughly check whether a module dead or still alive by applying load and measure the closed circuit voltage. For the whole pack to perform, all modules have to behave similarly in conformance with each other under the same load. And that can only be done on the High Voltage Battery Analyser.